Welcome to today's lesson. Today's lesson is differentiation. On my board, I have drawn a curve y is equal to x squared. You can be able to see the curve very clearly. If I may ask, I have so many points on this curve. So I can have this point A, I have this point B, I have this point C. So I can ask you a question before we move on. How do we get the gradient at this point A? Or how do we get the gradient at this point B or at the point C? And definitely the answer that I'm expecting from you is you first draw a tangent. Then you find the gradient of this tangent. And if you find the gradient of this tangent, then it will be the gradient of this curve at this point. The same thing will happen here at point B. You draw a tangent, then you find the gradient of this tangent. Because this tangent is a straight line, then now you will be able to get the gradient at this point C. At this point B. At point C, you will do the same. Now, in this video, we are going to learn how simply we can get the gradient function. The gradient that will be governing this, the gradient function that will be governing this function all throughout the curve. So, for example, if I have a point y is equal to x squared, I just need a gradient function for me to get the gradient at this point A, at this point B, at this point C. So, how do I get the gradient function? This is the simplest way we are going to use to get the gradient function. So, the gradient function, first of all, it is being abbreviated using this one, dy dx. This is what you call a derivative. We are going to see how we are going to use it to get the gradient function. So I will move down and say my dy dx is equal to, I'm going to now get the gradient function from this. And I'm going to bring these two here. It's going to be 2x, then 2, I subtract 1. You see what I've done? I've just brought these two here, which is here. Now, the same 2 I've subtracted from 1. And this is going to be 2x. So, my gradient function dy dx is the same as 2x. So, what does this one mean? It means that at this point A, if I take the point for this x-axis, for example, 5, and this one maybe, for example, 10, and maybe this one, for example, 20. If I want to get the gradient at this point A, I just need to substitute the value of x on this equation. So for the point A, I will say the gradient is going to be 2 times the value of x is 5, and this is going to be 10. And at the point B, I'll say it's going to be 2 times 10, which is equals to 20. And at point C, we'll have, it's going to be 2 times 20, which is going to be 40. So it means, assuming the points A, B, C, their x values, they are 5, 10, and 20, I can get the gradient at that point by just substituting on this gradient function. So the gradient function is 2x. So it's going to be 2 times 5, which is going to be 10. At point B, the same. At point C, the same. So this is the simplest way of getting the gradient function, and the process of getting the gradient function is called differentiation. So in this topic, we are going to get the gradient functions for each case, and that process is going to be called differentiation. So a good example is, I'm going to have maybe another example too. Find the gradient function of, find the gradient function of y is equal to x cubed. So the easiest way is to write dy dx, that is the gradient function. That's how it's called a derivative actually. So it's going to be, you bring 3 here, it's going to be 3x power 3 minus 1, and this is going to be 3x squared. This is the gradient function of this curve. Another example is, maybe you want to get the gradient function of y is equal to 2x power 2 plus 1. So it is good to note that this one, the gradient function, it will be dy dx is going to be, you bring this to here, it's going to be 2 times 2 x power 2 minus 1. Then it is good to know that this is a constant. This is a constant. Anything without the value, the x, it is a constant. So the derivative of a constant is always 0. So this one will be 0. So it's going to be 2 into 2 times 2x, 2 minus 1. And the answer is going to be 4x. Because 2 minus 1 is 1. So the gradient function is 4x. So the process of getting the gradient function is what we call differentiation. So there is a general rule for differentiation. For example, if you have the function y is equal to x power n, there is a general rule to differentiate this, and I will say now dy over dx is equal to, if you bring n here, it's going to be n x power n minus 1. This is the general rule. This one I can call it the general rule of differentiation. So this is how we can be able to differentiate it. We are going to look at a little bit more examples. So another good example is differentiate. Now, example 3. Differentiate y is equal to x minus 2, x plus 2. So you can be able to see, this is a very good example to show us something. That this one, we can be able to differentiate it fast by expanding. We have to expand this bracket. So we'll say y, if you expand this, is going to be x squared minus 4. I hope we are okay. So if we find the derivative is going to be dy dx, it's going to be 2. So you bring 2 here, it's going to be 2x, then 2 minus 1, then minus the derivative of 4. This is a constant, it's going to be 0. So the answer is going to be 2x. That's how we can be able to get the derivative. Let's think about example 4. And in this case, we are going to look at the polynomial. A polynomial has more than one term in the expression. For example, I have y is equal to x cubed plus x power 2 plus 1. So how do I get this? This is a polynomial. If I want to differentiate this, I want to differentiate. So I'll say dy dx is equal to, you bring 3 here, it's going to be 3x power 3 minus 1 is going to be 2. Now you know that, I don't need to write. Plus, you bring 2 here, it's going to be 2x, 2 minus 1 is 1. So plus, this one, the derivative of a constant is 0. So the answer is going to be 3x squared plus 2x plus 0. Or we can choose to remove 0. So in this case, what we are doing, we are differentiating y with respect to x. So in other cases, like now here, we were also differentiating with y with to respect to x. So we are differentiating y with respect to x. That's why we have dy dx. So here the same, dy dx. So here the same, it was dy dx. So what we can say, mathematically, we are differentiating y with respect to x. I'm going to do the last example, and you are going to do the others now. For example, differentiate y is equal to, differentiate with respect to x. So y is equal to, I have x power 4 plus x power 3 plus x, yes, plus 7. This is a polynomial too. So we are going to say dy dx is going to be, you bring 4 here, so it's going to be 4 times a half x power, you subtract 1 from 4, it becomes 3, plus, you bring 3 here, it's going to be 3x, you subtract 1, it's going to be 2, plus, the derivative of x, it is 0. It is 1. So plus 1, plus the derivative of 7 is 0. So plus 0. So here, dy dx is going to be, this is going to be 2x cubed plus, this is 3x squared plus 1. So it is good to note that the derivative of x is always 1. Why? Because x is believed to be raised by 1. So if you bring 1 here, it's going to be 1x1 minus 1. And this is going to be 1x power 0. And this is going to be 1. Because x power 0 is 1, 1 times 1 is 1. So this is the derivative of x will always be 1. So that is why I want to insist here, so that you can be able to know why we have 1. Thank you. Have a good day.